Okay, it's recording. Okay, this is our first lesson, 1.1.1, Algebraic Expressions. So I think you've seen some of this before. I'll ask a couple questions. Have you seen algebraic expressions that have exponents in them? You've seen those before? Okay. You know a little bit about each of the terms, what to call them, and the different vocabulary. So we're going to go over that pretty quick. Okay. You can think of this as the difference between an expression versus an equation. What's the difference? Expression versus an equation.
Expressions that don't have equivalent signs.
Perfect. Perfect. An expression just denotes a set of terms, and it does not have an equal sign. You can't find a solution for an expression. You can only simplify it down to its most simple form, basic form. So that's our basics here. We're talking about expressions. And here are some of the vocab you may already know. You may not know. No big deal. But who can help me out and tell me about where should I put an E to show that it's an exponent? Where do we see an exponent? Where do we see an exponent in this expression? Exponent is? Good. And it's 4 times x raised to the second power. So this is my exponent, the 2. How about coefficients? Where do we see coefficients? Yes?
The 4 and the 2.
The 4 and the 2. The coefficient is always the value that's multiplied to the variable. So we have a coefficient, we have a coefficient. That's it. Remember, it's 2 times x squared. It's 4 times x squared. It's 2 times x. Let's see. Variables. What kind of variables do we have? Yeah. The x. Here's an x. Where else? The other x. That's it. The variable. It's just an unknown. Within the same expression, these x's are going to have the same value or values as a solution if we could solve it. Okay. So we know those are the variables. How about the constants or constant? Gabriel, what do you think?
8 is a constant.
8 is a constant. And we can say it's a constant because it's never going to change. 8 is always 8. I don't care if you multiply it and divide it, it's always going to be the same. It's constant. Variables, it varies. It could change. We can have any value for an x value, as long as it balances the equation. Where do we see our base? And I'll tell you, base is related to the exponent. So what are our bases?
X.
Okay. So we have the base here, and, well, you said x. Did you mean both of them?
Yeah.
Okay, good. Because we have x here as our base, and why is this x here a base? What is the exponent that's applied to that x? Yeah. 1. Whenever you see, if you have just the value x, it is x to the first power. It's just the first power, so it's going to be itself, right? So don't worry if you see x. You know that there's an x to the first power. It's just the first one, so they don't do that. Just like you see the third root right here, the cubic root. You may not have seen that before. You may have only seen this. What's this symbol? Square root. And officially, or in terms of the pattern that's followed, if I have the fourth root, the third root, we don't put the 2 here because it's the first root you could take. It's the same idea as when you have x to the first, it's just equal to x. You may not see that exponent there. The same thing with the square root. That 2 within the root symbol is saying it's a square root, but because it's the first root you could take, we just call it the square root without that 2. Okay. Just trying to point out some patterns that might help the whole system make more sense. Okay. So those are just our expressions, IDing the vocab there. And now let's look at this. Is anybody on the wrestling team? I know that there are boys and girls on the wrestling team here, so no one. Okay. My examples are always going. How about anyone do martial arts, do anything like that? No one. Okay, crickets. All right, my third example. Let's see. Who plays soccer? Thank you. There's some soccer players. Good. Okay, so say if you're the sweeper. Sweeper is like the back, center fullback. They're the main defense, like last defense. If you're walking in, you see the other team walking in as well, and you're the sweeper, so maybe you're like 6'3". You're tall. Okay. Who are you going to be sizing up on the other team? who do you think you're going to be going up against? If you were the sweeper, who's that? You know, the striker. So the offense on the other team, you might look and you're not gonna go and try to size up and see if you can beat, you know, their left back. You're not going to look and see, can I beat their defense? You're going to look and see, can I beat their striker? Can I beat their offense, right? And the striker's usually also a tall person, so you're probably looking at the other person that's like tall. You're kind of sizing up. If it was wrestling, you were a lightweight, you'd be sizing up the other lightweights. You wouldn't be sizing up the guy that's 250 pounds, right? Because you're never going to have to compete with that person. I'm trying to give you the idea here of the categories with like terms, which first off, I want you to write this. Like terms are based on exponent. Based on the exponent, okay, we have the like terms, the wrestling matchup. Who's going to be wrestling with the other person? Okay. And that's a real just simple mnemonic device to help remember this. If it's based on the exponents, then what is a like term with 4x squared? Yes?
Negative 3x squared.
Negative 3x squared. I look to the exponent to tell me if it's a certain type of term. Okay, how about 3x matches with what? Yeah? Matches with x. X to the third power. Gabriel?
5x to the third power.
5x to the third power. 8. 81. Okay. Now, if we had to combine these terms, you can only combine terms that have, you can only combine like terms. So if we were combining these, instead of thinking of add or subtract it, think of it as combining. And the reason being is let's look at our 4x squared and negative 3x squared. So if you have 4 of the x squares and you have negative 3 of the x squares, when you combine them, what do you get? You get x squared. So if we combine, here's what we get. Because you have a positive 4x squared, you have a negative 3x squared. Here's the type of term, here's how many of those there are. So we get x squared, because we would just have 4 minus 3. Okay. All right, how about, let's see, 3x and x, combine those, you get positive and positive, 4x, 8 and 81, 89. X to the third and 5x to the third, combine those. 6x to the third. All right, that's it. So this is really, really intro, the numbers 1 and 2. We're going to get to some nuts and bolts over here, but I like to check in with the class. Thumbs up means all good, keep going. Could even mean too slow. Sideways is like, I got half of that, I think I could do it with the classwork. Thumbs down, I need another example, and that's how I'll know. So give me a thumbs up, sideways down. I like to see it from everybody, please. It really does help me pace this out. Okay, so if you're rocking, that means that maybe you see another example, maybe with the classwork you'll have it. Thank you for those thumbs, perfect. Okay. So we'll come back to this and we'll be engaging in these concepts as we do the rest. So just wait for it. Okay. Now, next, we can do it. Oh yeah, look at that. How slick. Not slick. Yeah. Thanks for braving that. All right, factoring. So with this, all right, perfect. We are gonna do it in one method using the expand method. I use the expand method a lot. Expand method's kind of like an accordion. You expand it out to see all the parts. You combine what you can press it back, and you're done. Okay. All the rules with factoring, if you follow this process, it's just like when you did this. You know, when you had 12, divided by 5, right? It's like a method. Anybody start doing this? Remember when you did this? When was this? Like 4th grade, 5th grade? You can't. 5 doesn't go into 1. 5 goes into 12. How many times? 2 without going over. Multiply it down. 10. Then you subtract. Then you drop down. One of the values, and we get 2.4. Remember how this is like a process. You can almost do it like automatic. It's spatially organized in a way that helps you figure it out. This expand method with factoring is the same exact thing. I'm trying to give you like a method that will work 100% no matter how complicated it gets. Okay, so just know this is the method you can use every time. First step, we need to factor tree each of these terms. If you can factor in your head and you know all the basic parts of each of those terms already, go for it. If not, this is what I would do. Go ahead and write 4x squared there. And let's break it into first the numbers and the variables. So split it up. And then what does 4 break up into? 2 times 2. If you keep dividing 2, you get 2 and 1, 2 and 1, 2 and 1, 2 and 1. Forever. Don't do that. If you run out of paper, you'll waste paper. You're going to get to the prime terms. What does x squared break up into? What times what? 6x. X times x. Good. Now watch what I'm going to do here. Under the 4x squared, I'm going to put all those prime factors in one column. 2, 2, x, x, and then watch where I put the n. 1. If I multiply all these numbers together, I get 4x squared. 2 times 2 is 4, times x is x squared, so 4x squared times 1, 4x squared. The 1 in there is going to help us when we get to challenging parts. Okay. How about 6x? Go ahead and factor tree it real quick. 6x, 3, 2. Go any further, we'll get 3 and 1, 3 and 1, 3 and 1, 2 and 1, 2 and 1, 2 and 1. We don't want that. We're going for the prime factors. Can't be divided any further. Let's go ahead and put those in the column. 3, 2, x, 1. And last is 8, 4 and 2, 2 and 2. So we have 2, 2, 2. This is a process. After you see it the first time, you'll see, oh, that's why we set it up this way. But so far, so good. You see what we did? Thumbs up, sideways, down. So far, so good? Okay, perfect. So here's the deal. We now know all the prime factors of each of the terms, so factoring is going to be pretty easy. What is in common between all 3 terms? Exactly in common. 2. So I want you to circle a set of these 2's. Is there anything else in common? Nothing else in common, right? Yeah. Ooh, but over here. Nice. And I forgot, we should put a 1 right there. But not quite, not quite. Let's go ahead and put our parentheses, because when we factor something out, essentially it's the opposite of distributing the number. Instead of distributing a 2 to each term, we're taking a 2 out. We're dividing a 2 out. Okay. So because I was able to pull out a 2 in common, that's going to go out here, 2. I was able to divide out a 2 from this term. Divide out a 2, divide out a 2. What is left in the first column if I multiply those together? Multiply my 2 times the x, what would I get? Yeah, say it out. 2x squared. That's what's left over in that term. We circle what's in common, we pull that out. What's left over in the column is what's left over in the term. We have all positive numbers here, so multiply these together and we get 3x. Multiply all these together, we get 4. Yeah, we took a 2 out there, so we couldn't get 8. That's the answer. It'll work if you have really huge coefficients in 20 terms. It doesn't matter. And that would take a lot of time. But this is 100%. This will work every single time. Let's see. I don't know where. All right, we're good. All right. Thumbs up, sideways, down. Give me a strong sideways if you just need another one. You guys see another one that maybe is a little trickier. Still okay? No problem. Let's do one that just has 2 terms, but it'll help us because we're going to get a different example here. Let's go with 18x squared minus 6x. Okay, make your columns. After you've seen it once, this saying it out loud takes me like 5 minutes to say it. Once you start doing it, it's like a minute or 2 for each problem. You do it quick. All right, so let's break 18x squared up. 18x squared. X, 9, 2, 3, 3. Let's just break it up, break it up, break it up. keep doing that. All right, so we have a 3, a 2, an x, an x. Negative, thank you. Are you saying 1? No. Correction of teacher gets candy. Perfect. We had to put the 1 in there as well. Okay. It's helpful for what's coming up. All right, how about this negative 6x? How about 3, 2, x, and in this case, negative 1? So what I just did was negative 6x is 3 times 2 times x times negative 1. You could have factor treated. I just did it this way. All right, what's in common? Tell your neighbor what's in common.
3, 2, and x.
All right, let's see. Jackie, what is in common? Would you and your partner figure here? The 3. Anything else? Okay. And the 2's? And the x's, right? All those are in common. We have them in all the columns. So I want you to figure out with your neighbor, since these are in common, we got to pull them out. But what do you think we're going to do? What number are we going to put out in front here? So go ahead and figure with your neighbor. Just ask them real quick. What's going to go right here?
Our neighbor 6. Maybe multiple all together. No, I think maybe 6. You multiply them too.
Okay, I see a lot of good discussions in there. How about Quinn? What do you think? What did you and your neighbor say? 6x. So essentially, what did you do with the term that was in common, or the value that's in common? You did what with all of them? Multiplied them together. Okay, perfect. So we have 6x here. Raise your hand if you thought it was 6x. Raise your hand if you thought it was 6x. Okay, we're doing all right with that. That's good. Now, let's see. We'll go with Leah. What do you think is going to be left over in that first term right here? What's left over in the column is what's left over. 3 times x times 1, 3x. Perfect, thank you. And let's see, is that... Nicholas, help me out with this. What's going to be left over for the second term? -1. Done. That's it. Because it's what's left over in the term. Look, gone, gone, gone. -1's left. That's it. Okay. You seeing it? Okay, now that we're done with another example, thumbs up, sideways, down. Let me see. You might need maybe some more practice problem. All right, we're good. Good job. Stuck with that one. All right. Now, this second part, raise your hand if you hate word problems. Be honest. Not everybody. Okay, perfect. So I'm teaching the same not phobia around this. When they mix words and letters, it gets confusing. Sometimes it's not in the same order that you would write the equation. They say it differently. But we need to look at the key piece of information that are helpful here. So tell your neighbor, what is, if I'm just looking at this part right here, that number sentence, what are the important parts of that? Like, what are the key phrases? What are the key numbers? What should I focus on? All right, Isabel, what is one thing we need to focus on?
When it says more, 2 more.
Good. 2 more. If I have 10 cookies, you give me 2 more, how many do I have? 12. That's logically easy to conclude, right? If I have a certain number of cookies, not 10, I have a certain number of cookies, we'll call it x, and you give me 2 more, how many do I have? X, whatever they are, whatever the amount is, x plus 2. You see? So when we look at that, everything that I just said, I think everybody understood that part. If you have 10 cookies, you add 2, you get 12. If I have some number of cookies in a bag plus 2, I get x, number of cookies in the bag, plus 2. Okay? So we're going to do that. Let's see, what's another one here? How about Vanessa? What's another part that's important up here? 3 times, and I'm going to kind of underline all this. 3 times a number. Do we know what the number is? No? So that's x. How would you express 3 times a number? I have a bag of cookies. I don't know how many are in there, but the next day I have 3 times as many. If I call what's in the bag of cookies x, then 3 times as many would be 3x. So you see that this part here gives us the 3x. 2 more is talking about 2 more than you have. So altogether you see 3 times a number, 3x. 2 more than that, plus 2. 2 more than 3 times a number, 2 more than 3 times a number. You see it? Yeah, let's get some practice. I want you to do this one with your neighbor, and then I'm going to call on some folks. 12 times a number divided by 3. 12 times a number divided by 3. All right, let's bring it back up. You can win a Starburst for you and your partner if you want to volunteer for this one. Let's see, who hasn't been called on yet, though? Isabel just called on. You know this, I can tell you know this. Solomon, right? No. That way. Sorry, Joseph. I'm looking backwards. Joseph, thank you. Joe or Joseph? Joseph. Okay. So what did you and your partner come up with?
12x divided by 3.
Okay, so we have 12 times a number, 12x. Divided by 3, we're going to take this and we're going to divide it by 3. So let me see if I can do 2 at once. Don't throw a marker at you. It's the small things in life right there. All right. Isabel, how would you write this equation, though, this expression? How is it going to be written out? I can't leave it like this and say, there you go.
I would put 12x, and I would divide by the division sign, like right next to it.
Okay, so you would do this, and that is correct. But since we're going to be solving and doing, how else could I set that up? What is your partner think?
You could do long division.
12x over.
That's where I'm going to start. And then, Antonio, how would you reduce that to? What would that reduce to? What do you think? You want to ask someone else in your group? What do you think?
Can you 4x?
Yeah. Do you agree with that? Gabriel said 4x, 12 divided by 3. 4. The x is still in there. So that's how we're going to reduce. We'll see that more and more. It's perfect teamwork right there. We all got it. So these are a little bit tricky, but I really think that maybe with one more example we can do this. So how about this? It's 10 less than 5. Okay. 5 times, I can spell, a number. 10 less than 5 times a number. Try it on your own, double check their neighbor this time. Try it on your own, double check with the neighbor. Okay. Okay, and I will do Starburst partner round. All right, Isabel, you're first.
5x minus 10.
Good. What are the important parts?
Less than times a number.
5 times the number. I know 5 times the number. 5 times the number. But it's 10 less than that. All right, raise your hand if you got that. Perfect. All right, one hand, double. Nope.
No. Oh,
Man, it was possible.
green substance.
I think it has to be 2 hands. So I can juggle them. All right, how about the whole entire lesson? How do we feel about this? Thumbs up, sideways, down. Feeling good? Feeling sideways? Don't even worry. If you're ending up right here the first couple weeks, just a little rusty, I'm here to help during classwork. And I think everyone gave it a really strong focus, so that's perfect. One other thing I'd like to do is to encourage all my viewers, because on my YouTube channel I now have 500 people. So I just want to encourage all my viewers to tell your friends to subscribe And I like to yell it at them every single time. So we're going to do subscribe on 3. Can you handle that? Do it all right? All right. Subscribe on 3. 1, 2, 3.
Subscribe!
That wasn't loud enough. 1, 2, 3.
Subscribe!
All right, that'll get them. All right, subscribe.